What if, in contradiction to special relativity, matter and energy are distinct entities? Special relativity, formulated by Albert Einstein, revolutionized our understanding of space, time, energy, and matter. At its core, it suggests that space and time are intertwined into a four-dimensional fabric known as spacetime, and it introduced the concept of mass-energy equivalence through the famous equation E equals mc squared. This equation states that mass, m, and energy, E, are interchangeable. They are different forms of the same thing. If mass is somehow converted into energy, it also shows how much energy would result and vice versa. If we entertain the thought that matter and energy are distinct entities, contradicting the core principles of special relativity, a lot of physics, as we understand it, would have to change. Here's what could happen. Mass-energy equivalence. If matter and energy were separate, the principle that E equals mc squared would be invalidated. The concept of mass-energy equivalence is fundamental to many aspects of modern physics, including nuclear reactions and particle physics. Without it, these fields would need to be rethought. Nuclear reactions, such as those that occur in the sun and nuclear power plants, rely on the conversion of a small amount of matter into a large amount of energy. If matter and energy were distinct, this would no longer be possible, and these reactions would need a different explanation. Particle physics. In particle physics, particles and antiparticles annihilate each other, converting their mass into energy. If energy and matter are not equivalent, this would not be possible. We'd need to find a new explanation for this observed phenomenon. Cosmology and Big Bang theory. Our understanding of the Big Bang would also be different. The Big Bang theory explains how the universe expanded from a very high density and high temperature state, where energy eventually cooled and coalesced into matter. If energy and matter are distinct, our understanding of the universe's origin would need to be revised. Quantum field theory. Quantum field theory, the basis of modern particle physics, relies heavily on the idea that particles can be created and annihilated, which involves the conversion of energy into matter and vice versa. Removing the interchangeability of matter and energy would fundamentally alter this theory. General theory of relativity. The general theory of relativity, which describes gravity as a curvature of spacetime caused by mass and energy, would also be affected. If energy and matter are distinct, the geometrical interpretation of gravity could be challenged. In short, if matter and energy were distinct entities, it would require a fundamental restructuring of physics as we know it. Many of the observed phenomena and experimental results would need new theoretical explanations. It's also worth noting that to date, special relativity and the equivalence of mass and energy have been remarkably successful in predicting experimental results, and no experiments have provided evidence against them.